Ever wondered how engineers decide the size of a beam in a building? Why some beams look deep and narrow, while others are wide and shallow? Today, we'll break down how to calculate the depth and width of a beam. And I'll share simple thumb rules engineers use every day. Beams are horizontal structural members that carry loads like slabs, floors, and even walls, transferring them safely to columns. If a beam is too small, it bends or cracks. If it's oversized, it wastes materials and money. That's why proper design is essential for both safety and efficiency. Let's start with depth. The depth of a beam mainly controls bending. A deeper beam is stiffer and resists sagging. The common thumb rule is simple. For simply supported beams, depth should be about 1/12 to 1/15 of the span length. For continuous beams, depth should be about 1/15 to 1/20 of the span. For example, if a beam spans 6 meters, its depth should be roughly between 300 and 400 millimeters. Now, what about width? The width of a beam controls shear and helps resist lateral buckling. Thumb rule: beam width is usually 1/3 to 1/2 of the depth. So, if our beam depth is 300 millimeters, the width should be around 150 millimeters. Of course, these thumb rules are just starting points. The actual design depends on many factors: the grade of concrete and steel, the type of loads applied, and safety factors defined in building codes like IS 456 in India or AXI 318 in the US. Structural engineers always run detailed calculations before construction begins. Let's do a quick example. For a 5-meter simply supported span, depth equals span divided by 12, about 420 millimeters. Width equals depth divided by 2, approximately 210 millimeters. This gives a safe starting point, and then reinforcement and detailing would be finalized by an engineer. Here's something interesting. A typical house beam for a small span may only be 230 millimeters wide and 300 millimeters deep. But in bridges or auditoriums, beams can be over a meter deep to carry heavier loads. Scale makes all the difference. Another important point: mistakes often come from ignoring load types. A beam carrying only floor slabs may follow the thumb rule easily, but one carrying heavy walls, machinery, or dynamic loads like vehicles needs much more precise design. That's why thumb rules are best for early planning, not final construction. So next time you walk under a beam, you'll know the science behind its size. Thumb rules give engineers a quick estimate, but real safety always comes from proper design and building codes. If you enjoyed this engineering explainer, hit like, subscribe, and drop a comment with the next topic you'd like to see explained.